This video is an interlude where I'll talk about symmetry. You probably noticed that this domain D that we've been integrating over is symmetric. It's symmetric across the x-axis, and if we reflected it, the two halves would line up. Domains can be symmetric in different ways. In this case, it's a reflection across the x-axis that's a symmetry of this domain. And the integrand, the function we're integrating, stays the same under this symmetry. Because in our running example, the function we're integrating is x, and this function stays the same. It's unchanged by a reflection across the x-axis. That reflection changes the y values from plus to minus or minus to plus, but the x values stay the same. They stay unchanged. So what that means is, instead of this overall domain D that we've been looking at, we can split it into these two parts, and let's call them D plus and D minus, say. So our upshot is that the integral for D plus is the same as the integral for D minus. And that means that the overall integral is just twice one of them. So we can just work out one of these, say for D plus, and double the answer we get. Now, even this D plus is still a little bit of a funny shape, but it's simpler than what we've been working with. So we could slice vertically, and we would only need two regions instead of three that we did in the first segment of this video. Or we could slice horizontally, and then we still would only need two regions. Oh, maybe the horizontal was the first segment and the vertical was the second segment. Well, anyway, either way, it would be simpler than what we've done up to this point. Well, a little bit simpler. So that's how we could use symmetry to make this easier. And it's always a good idea to keep your eye open and see if you can spot symmetry and take advantage of it when it pops up.